Hello, welcome to Astronautics for Exploits. This is Dr. Ayenshola Ogudele. Deep Space Astronautics Technologies and Concepts. Futuristic space ideas for easy navigation of deep space and human eventual settlement on a celestial body. The focus points are as follows: Deep Space Technologies and Deep Space Astronautics Technologies and Concepts. Deep Space Technology are specialized technologies required for missions that travel beyond Earth's immediate vicinity, including the Moon and other planets and celestial bodies. Using the space astronautics principle, various technologies and concepts have been developed for deep space missions, such as planetary exploration mission. The missions have helped humans to study the composition, geology, and potential resources of planets, moons, asteroids, and comets. Because of human ingenuity, various futuristic advanced deep space technologies and concepts have been proposed and developed, such as solar cells, advanced propulsion, robust spacecraft, radiation shielding, and efficient communication systems, life support systems, inflatable structure, robotics and automation, and advanced materials. Solar cells are a method of spacecraft propulsion that utilizes the pressure of sunlight to propel a spacecraft, offering a propellant-free alternative to traditional rocket engines, enabling long-duration space exploration. The principle of solar cells is as follows. As photons bounce off the cell, they transfer momentum, pushing the spacecraft forward. Unlike traditional rockets, solar cells don't require propellant, allowing for potentially indefinite travel and missions to distant parts of the solar system. This is very useful for long-duration deep space missions. Robotics and automation technologies are increasingly vital to deep space exploration, enabling missions to explore Earth's environments, perform tasks too dangerous for humans, and assist astronauts, ultimately making space exploration more efficient, cost-effective, and accessible. These space technologies are specialized technologies required for missions that travel beyond Earth's immediate vicinity. Using this space astronautics principle, various technologies have been developed for these space missions. The missions have helped humans to study the composition. Illustration of a Mars transit habitat and nuclear propulsion system, which could one day take astronauts to Mars, is shown in this picture. These space astronautics technologies and concepts are as follows: advanced propulsion, communication and navigation, alternative, life support systems, robotics and automation, 3D printing in space, inflatable structure, and advanced materials. Advanced propulsion systems explore technologies beyond traditional chemical rockets using this space astronautics, including electric propulsion, nuclear thermal propulsion, and theoretical concepts like quantum vacuum thrusters. Electric propulsion, nuclear propulsion, propellantless propulsion are examples of advanced propulsion. An artist's rendition of an antimatter propulsion system is shown in this picture. Nuclear thermal propulsion system uses a nuclear reactor to heat a propellant such as hydrogen, creating a high-velocity excess for propulsion, while the nuclear electric propulsion uses a nuclear reactor to generate electricity, which then powers electric thrusters, offering a combination of high frequency and high thrust potential. Propellantless propulsion is a theoretical concept that proposes exploiting quantum vacuum fluctuations in order to create thrust without the need for propellant. Spacecraft propelled by nuclear fission is shown in this picture. Solar cells are a method of spacecraft propulsion that utilizes the pressure of sunlight to propel a spacecraft, offering a propellant-free alternative to traditional rocket engines, enabling long-duration deep space exploration. Antimatter propulsion is a theoretical concept that proposes exploiting quantum vacuum fluctuations, Artist's concept of an air-scooping electric propulsion satellite is shown in this picture. Communication and navigation is another deep space astronautic technology. Space communication refers to the transmission of data between Earth and outer space using specific frequency ranges that pass through the atmosphere with minimal attenuation. Space navigation involves guiding spacecraft through the cosmos, relying on sophisticated technologies and celestial mechanics. Artist's concept of advanced composite solar cell system unfurling in space is shown in this picture. Spacecraft engineers employ astronautics to help communication in deep space. Using lasers for high bandwidth communication in deep space offers faster data transfer rates than radio waves. Artistic rendering of the HTTN protocol being used on the lossy communication relay demonstration to transfer radio and optical communications between the Earth and space is illustrated in this picture. Autonav. The Deep Space Autonav developed by NASA is an autonomous navigation system that allows spacecraft to determine their position and trajectory in deep space using passive optical data, eliminating the need for constant communication with the Earth. It is an onboard system that uses images of known bright asteroids against the backdrop of fixed stars to determine the spacecraft position and trajectory. Victram lander mounted on top of orbital is illustrated in this picture. Autonav can be used to acquire targets for scientific instruments by tracking the position of bodies relative to the spacecraft. It is a key technology for future deep space missions, enabling more autonomous and efficient exploration. NASA's Falcon robot is illustrated in this picture. Life support system research and development are focused on creating more efficient, lightweight, and closed-loop life support systems for future deep space missions. Various space agencies are performing research and development on life support systems. Australia's mission is illustrated in this picture. Robotics and automation are increasingly vital to space exploration, enabling missions to explore Earth's environments, perform tasks too dangerous for humans, and assist astronauts. Robots can venture into areas with extreme temperature, radiation, or hazardous terrain that are too dangerous for human explorers. Scheme of the architecture for the planned deep space optical communication is illustrated in this picture. Robotic missions are often cheaper and require less resources than manned missions, allowing for exploration of more distinct or challenging locations. Mars rovers like Curiosity and Perseverance explore the Martian surface, collecting data and searching for signs of past or present life. Deep Space One asteroid and comet mission is illustrated in this picture. 3D printing allows astronauts to create tools, spare parts, and custom equipment on demand rather than waiting for supplies to be sent from the Earth. By manufacturing parts in space, the need for transporting large quantities of material and equipment to space is reduced. Illustration showing NASA's New Horizons spacecraft in deep space is shown in this picture. Inflatable structure use pressurized air or gas to maintain shape and rigidity. NASA is testing a deployable heat shield in space as a secondary payload. Artist's concept of a Mars exploration rover is shown in this picture. Advanced materials. For deep space exploration, advanced materials like self-heating helium polymers, multifunctional carbon fiber composite, and radiation shielding material are crucial for building robust, lightweight, and efficient spacecraft habitats and life support systems. Artist's depiction of NASA's Psyche and Lucy mission is shown in this picture. For more information, contact Astronautics for exploits. You've been listening to presentation on deep space astronautics technologies and concepts, futuristic space ideas for easy navigation of this space, and human eventual settlement on a celestial body, presented by Dr. Ayoshola Ogundele, with the focus points deep space technologies and these space astronautics technologies and concepts. Thank you.